Thanks a lot for the opportunity to talk a little about my work. I'm Luiz. I'm doing this work alongside my advisor, which is Aline Paes. So let's talk a little about our research problem. So figurative language understanding is very important for language models, being an important tool for human communication. And metaphors are one of their most creative manifestations. The following image in my slide exemplifies literal and non-literal uses of the verb flew. In the first sentence, we see that the source domain, which is organism that flies, is juxtaposed with the target domain, which is speed, to describe the subject speed in terms of an abstract ability to fly. In the second sentence, we see a literal use of the verb. So, studies have shown that language models have challenges to deal with metaphors, but also have this knowledge. As such, we investigated the extent of it, using the conceptual metaphor theory as a framework and two LLM flavors, a bigger closed-sourced one and a smaller open-source one. The conceptual metaphor theory defines metaphors as mappings between source and target domains, where one is described in terms of another, just like the image that I just presented you. So for data sets, we used typical metaphor interpretation ones. And among many of them, for both trophy and Veerway, we used the metaphor we used for metaphor classification, as they include sentence and metaphor presence indicator pairs. Otherwise, for metaphor list and LCC, we have the conceptual metaphor domain information, and as such, we used them for conceptual metaphor inference. LCC, additionally, also include information for conceptual metaphor lexemes. On the right side, we can see the proposed tasks and their respective prompts. Metaphor classification is performed by asking the model whether a given sentence is metaphoric or not. In this case, we expect a binary yes or no answer. Two metaphor domain inference tasks are proposed, one where the model is prompted to find the source, and another where the model is prompted to find the target domain given a metaphorical sentence. The answer space in that case is open-ended. For conceptual metaphor lexeme inference, we have the idea that we need to find the lexemes associated with the source and target domains of the metaphorical expression. The answer space, in that case, maps to the set of lexemes present on the given sentence. For experiments, we used GPT-3 as the ideal performance to be reached by Llama 2. Llama 2, the model with the 7 billion parameters, is our baseline. And a fine-tuned Llama version was trained for each task and dataset pair. Our experiments were run on a low-resource Google Colab environment, and as such, instead of fine-tuning all model parameters, we employed parameter-efficient tuning techniques, like quantization and low-rank adapters. During fine-tuning, no few-shot examples are prefixed to our input prompts. But during testing, we appended few-shot examples to each task prompt for each task before asking the model to answer a question. The number of few-shot examples was chosen on the dev set on a model, task, and dataset pair basis. No global number of few-shot examples was defined. As preliminary results, we can say that for classification, the fine-tuned Llama model was better for most metrics. However, its results on trophy indicate a strong misclassification rate, a scenario pending further investigation. For conceptual metaphor domain inference, all models found easier to infer the target domain. The target domain is normally trivially derivable from the metaphorical sentence, which may explain the result. For conceptual metaphor lexeme inference, GPT-3 had the best results overall across tasks. During evaluation, we also saw that Llama 2 produced verbose responses, often including the gold label, answer, followed by an excerpt of the input prompt context prefixed. To conclude, metaphoric knowledge do exist on large language models, varying between both models explored here. Results is likely above chance were achieved for all models on each task, which the observation that fine-tuned Llama 2 results on trophy were worse, signaling an improvement area. As ongoing work, we are devising methods to map available metaphor knowledge inside the model. Also, we are studying smaller and linguistically aware language model architectures to solve the downstream tasks more efficiently. And finally, external knowledge bases may clarify the results obtained. Here we have some acknowledgements for our research sponsors, these large references, and that's it. You can find the code using this QR code. Here's our contacts. And do you have any questions?
Thank you, Luis. People were clapping. I'm not sure you heard that, but I think we appreciate it. Are there any questions? Please go to the microphone or raise your hand. There's one question.
Hello, can you hear me?
Yeah, sure. Hello.
Okay, so hi, I'm from Brazil as well. And I have a question because I mean, if I understood correctly, your data set is all in English, is that correct?
Yes, is that correct?
Is there any plans to do anything in Portuguese? Because I don't want to diss the English language, but I think Portuguese, especially Brazilian Portuguese, is very, very like there's many flavors and we are really good with metaphors. So do you have any plans towards that direction?
Yes, we discussed a little about this. The main problem is that we didn't find yet a benchmark data set for metaphor interpretation in Portuguese. So we may have the need to create one.
I see.
But this is a very great a question because the Portuguese language is very rich in vernacular, just as you said. And we are interested in understand not only how those models perform for metaphors in English, but also across multiple languages. So this is really something that we can take a further look later. Also for other Latin American languages, such as Spanish, we also saw that most metaphor interpretation works related to this area also involve English and only English and not to other languages such as Spanish. Sure.